I welcome Abhishek. Welcome Abhishek to the 17th World Education Summit.
Yeah,
Hello,
hi,
Abhishek.
thanks, thanks, Ravi.
Thanks for joining, Abhishek.
Right.
Welcome.
Okay, so just a quick question here. So I have a few questions, polling questions here.
Yes,
So they are already uploaded.
yes, they are uploaded on our 3D platform Avatar.
All
So
right,
once the slide will come, the polling will be done. So I will announce the how much people have done the polling for the particular answers.
all right then. Thank you so much. So a very good afternoon to all of you, all the principals, teachers, school owners, speakers, and all the listeners. I am Abhishek. I am co-founder and director of Open Door Education. We are into this sector for the last 7 years, and we have been working with lots of schools in India and Middle East. And our philosophy of learning revolves around thinking. We make students think. And in the previous session, in the session at around 11 o'clock, I was listening to the speakers, and and similar kind of thought process was resonating among the speakers, those who were speaking. And there was also a discussion around the relevance of school, physical school system, now that all the schools classes have moved online. So there were questions regarding that, and answers were really interesting. That some of the words that were spoken was about localization and physical interaction with the teachers. Now, we all know that when a student is in a teenage, around 20 years, he has spent more than 50% of his time in schools. He has spent more than that with the teachers, right? So there's no denying that teachers have lots of impact on the life and the thinking process of students. But here I am with one different thought process based on the experience of our organization and based on my own experience of academics. So just talking about myself, I was a very curious kid as a student. I used to always pester the teachers with lots of questions. So we always think within our open door regarding these questions. And when I was preparing for this presentation, I was thinking about my school days, and I was trying to think which are the teachers, which are the classes that I still remember. I went back almost 13 years. I went back into 8th standard, and I tried to recollect some of those classes. And and the results, the what I recollected was something very, very surprising. So here's a simple exercise for all the listeners here. Just while I'm speaking, just try to think of the science classes, particularly when you are in grade 8. What all do you recollect? What are the examples and what are the teachers do you still remember? And I'm sure you will find something really interesting. So while you are thinking, I'm going to share my experiences, my thought process, what I. So my screen is audible, Abhishek.
Yes, sir, it is visible. Right.
All right. So now this all revolves around why certain things sticks to our mind when we look back 17 years back. We still remember some of the concepts. We still remember some of the experiments or any classes that we never thought we would remember. So here's a simple story that I would like to share. I was studying in grade 8B. So there were two sections in my school, 8A and 8B. So let us call the teacher Mr. B, who used to teach us, and Mr. A used to teach grade 8A. And they used to be independent teaching, so little interaction among the teachers, but the syllabus was same. So Mr. B was a very good teacher. He was regular. He used to explain all the concepts very well, finish our classes, and he used to also do experiments within class. Now, one fine day, Mr. B fell sick. So, what usually happens when a teacher falls sick? When a teacher falls sick, there is a replacement. So, obvious replacement was Mr. A. So, Mr. A had to come to our class, and we could really see that Mr. A was not prepared, and since it was just one class, he wanted to just kind of pass the class because I mean it was just one class. So we could really read his face, and some of the thoughts like this were going into his mind what to teach these students in just one class. So he came up with the ingenious idea that let me give them one difficult question and the class will be over. So he did same. He gave us one interesting question, one question which we all knew, but we had never kind of worked upon it. It was a science question. So question is not very important. The process, the thought here is important. So he gave us a question, and every time we were answering, the question was not that easy. Every time we were asking, he was commenting in this manner. No, that's not exactly correct. Think again. You are close. Discuss among yourselves. He was but enjoying all our answers. He was very pleasing in conducting the discussions, but he barely taught anything in 1 hour. He counted all our answers, but at the same time, he gave us space to think. He gave us at times a direction to think. Now, here's a question to all the listeners whose classes are still fresh in my mind.
So, Abhishek, maximum people has answered for the Mr. B's class 73% and rest Mr. A class.
All right, so that was a quick voting. So Abhishek, Mr. B has 73% have voted for Mr.
And
B,
yes, and Mr.
and
A
rest have
rest
voted. All right, all
27.
right. Okay, so there are still believers of Mr. A, and this is what happened with me. I barely remember any of Mr. B's classes, but I do still remember the class of Mr. A when we spent just 1 hour, whole 1 hour on just one question thinking. And this made me realize that what was it? What was it that made Mr. A's classes impactful? Was it his question? There's some problem.
Hello.
Hello.
Yes, Abhishek.
You can see the screen?
No, I can't see the screen.
Now you can?
No.
Let me reshare. I'm sharing has gone. Now you
Yes.
can see? All right,
Yes,
all
yes,
right,
yes.
all right. Sorry for this. Right. So, what made Mr. A's classes impactful and lasting for me? His question, I don't think his question was interesting, but not new to me at that time. I already knew that question. Then what? So, here's an important learning that I get from that reflection is that Mr. A gave us thinking time. He gave us time to reflect. He gave us space to us to work on that problem. Now, why this is important is because research says that thinking time given by the teachers across the globe, it is not only for India, everywhere is something around 1.5 seconds. And there are obvious reasons for it, is because teachers have lots of syllabus to cover, lots of things to do in the classroom. But something that suffers in all of these is the thinking time. I mean, students do not get their own time to work on a problem in the classroom and to discuss on it. So here's one conclusion of what makes science teachings last forever is the thinking time. So there has been a lot of research done on it. It is also called as wait time, that you give a question, let students think, wait for a while, and that is where real learning happens. It is not when we speak in the classroom. And if those questions can be interesting, it'll also add to the thinking time part. I mean, some of the questions could be why rotating Earth never stops. And in fact, we can ask the questions which Newton asked to himself, why does apple fall? I mean, we tell the story of the Newton to the students that Newton asked this question, but we never give student chance to ask the question. I mean, how about asking student in grade 6, why does apple fall, without telling him that Newton had to ask this question to find the gravity? And I'm sure we'll come up with really interesting answers from the students. So it is all about thinking time and giving them obvious question to think about. So here's the first conclusion of what makes science teachings last forever. Now I'm moving to the second part of it. Now second part is again very important. This is again from the experience of our work at Open Door Education, our personal experiences as students, is that teachers need to be students. We are all trying to find out different contents, different textbooks written in an interesting way, but the teachers or the educators are not spending time on being students themselves. So I'll come to a story again here and then we'll get into it much more deeper. So here I am with a picture of a beautiful fish, one of the most beautiful fishes in the world. And here is a picture of one of the most beautiful flowers in the world. And you can guess this is a picture of one of the most beautiful buildings in the world. And here I am with one of the most beautiful chemistry equation in the world. Does it look beautiful? Well, I mean, it doesn't look beautiful when you look at it. It looks very complex and ugly, a little bit ugly. But what if I say it is really beautiful? Now, why do I say photosynthesis is beautiful? Is because it is a process. It is a magical process by which plants can make food just from the thin air. They do not have to get raw materials per se. They do not have to walk for the raw materials. All that they need is air and water, which are freely available on this earth. Imagine if humans could do photosynthesis. Wouldn't that make our life much more easier? Because it is such a wonderful process wherein you don't need to buy a raw material. It is just available for free. But we humans haven't been our science till now, although there are research going on in creating artificial photosynthesis, but it is not with human in the human body. So now, the purpose of this example is finding the beauty in the concepts. So all the teachers out there, all the biology teachers and the chemistry teachers, they must have done mastery in photosynthesis. But at times we do not look at it in a different way. We do not appreciate it. We do not really value the concept because all we need is to teach the concept or clear the misconception of the student. But there is one more level of teaching that is called as concept synthesis. Concept synthesis, wherein we can find our own appreciation and the importance of the concept. I'll move on with this idea of concept appreciation and finding the beauty of the concepts, and I'll discuss few more examples. Now, this is what respiration looks like in a textbook, and there's a lot to study in it. I'll just give a read to it. Food molecules absorbed after digestion are taken in, broken down, and the energy freed in the process is used to power the organism's movements and physiological functioning. Respiration is the biochemical process in which the cells of an organism obtain energy by combining oxygen and glucose, resulting in the release of carbon dioxide, water, and ATP. So this pretty much sums up the process of respiration. Although there are several things to learn about is ATP, combining of oxygen and glucose, but all of these part are covered by the teachers in the classroom, and we say that respiration is done and the concept is clear. But let me share you one synthesis of respiration, how we can look at the respiration in a different light. So this is an engine. This is a car engine which generates energy. We fill in petrol inside it and it converts that chemical energy into mechanical energy, and that is how a car moves. Now, my question is, how many engines does our body have? Now, this is a polling question. All of you can take part in it. How many engines does our body have?
Let's give some time.
Sure.
There's option one, two, more than 100, more than a billion.
Right. So options are 1, 2, more than 100, or more than a billion.
So maximum, so I'm getting very less of this opinion. So maximum people have given on the more than a billion, like
All right.
40% more than a billion, and
40% more than a billion. All right.
yeah, and 25% given as a more than 100,
All right.
and some that's given as a one.
All right. So most of the listeners here are a good thinker, and the correct answer is more than a billion. Now imagine asking same question in a classroom. Do you really think that student would, in fact, after you have taught respiration, just teach respiration the way you do and ask this question? I mean, the usual answer would be either 1, 4, 5, because you usually associate engine with your heart, and but heart does not produce energy; it produces pressure, right? So this is what is the appreciation of respiration: is that each and every cell of our human body generates energy, and this is what is the beauty of respiration process. Is when humans design a car, they put one engine, and if something happens to the engine, the entire car stops working. But when human body is designed, that engine is designed in the billions, and when something happens to one engine, doesn't matter. In fact, we lose billions of engine every day. Right. So this is what is the beauty of respiration, as in how integrate, how nicely the entire process of respiration has been designed inside the body, that that it can even outsmart the engines, car engines of the most of the advanced cars, and not only, and those engines are not only one, but they are into billions. So this is again an example of synthesis of concepts by the teachers. I mean, the textbooks cannot write these things because textbooks have limitation. They cannot be very thick, and this is the task of the teachers to come up with such thought, so that they can build interest and long lasting impact in the class. Again, so there are a few more examples on this. So again, if the listeners are open to thinking, they can think is that we again teach atoms to the students. I mean, we teach atoms. There's a nucleus. There are electrons and protons revolving around the nucleus, and of course, we teach lots of concepts. And the concept is deemed to be completed over there. But again, when we dig deeper and try to look at it in different light, we find that atom is really amazing. And now I'll share my thought on it. So, atom is really amazing, is because the electron, proton, neutron in your body is similar to electron, proton, neutron in your cell phone. I mean, they are all identical. Only thing that differs is the structure of the atom, and that produces billions of varieties of material. Your bed is made up of same electron, proton, neutron. You are made up of same. The bulb is made up of same. This laptop is made up of same. So entire universe constitutes mostly of these three things, but yet the universe looks so different. Now, what lies at the center of it is the structure of atom. Again, this is an example of synthesis, how you look at the atom in your own way and present it in front of students. Okay, I'll digress a bit here from math, from science, and get into math, because math is also a type of science. They're interrelated. So let us say you have to again teach the concepts of power and exponent. So we have a number 2 to the power 64. So here's again a question for you, a voting question for you, is 2 to the power 64 is written in such a small space, And of course, it is a number. The question is, if you have a 2 to the power 64 rice grains, how many sacks would it occupy? One sack, three sacks, six sacks, or much more than that? So fourth option is much more than six sacks. Take time and just guess. I'll repeat the question. You have 2 to the power 64 rice grains, and you want to fill it up in these sacks. These sacks are of approximately of 20 kgs. And so yeah.
So I request audience, there is a polling. So there is a question that is asked by the Abhishek. How many sack 20 kg capacity would 2B power 64 rice grains fill up? Approximately 1, approximately 3, approximately 6, more than a billion sacks. So I request to please poll right now so that we can have the result on that. So Abhishek,
Yes,
maximum
Abhishek. Yeah.
70% people has more than a billion sack.
Hmm. All right.
20% approximately 3, and 8% approximately 6. So that's
All right.
one.
All right. So that's a great answer given by all the listeners, and most of the listeners here are pretty smart. And the correct answer is more than billions of sacks. And those who answered 1, 3, and 6, they did not feel bad because the number looks so small. To the power 64 looks so small a number, but that is the power of power, that when you put that number to the power 2, it is such a huge number that you cannot even think of. It is more than a billion sacks. You can go and check. There are several stories behind this sack story, but the whole idea is that how the concept of power can be shown to be valuable in the classroom. And particularly, maybe this is the reason the power is called as power, because it gives so much power to the number. Again, this is an example of concept synthesis. You look at a concept in a different light. How to appreciate irrational numbers. So again, there are examples of so irrational number you can teach. You can take things from the notebook and teach, but you can take a pause, reflect on it, and find out the importance of irrational number. So again, the appreciation of irrational number is that many of the equation in the physics, the constant in the physics, they constitute of irrational number. So I find it really amazing that a number that cannot be presented, that is not real and that cannot be written till the final decimal, how nature has chosen those numbers to be part of their equation. So here are some of the equation. You not worry about other terms, but look at the irrational number in all the equation of the physics. So here is pi, here again is pi, here again is pi, 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 and there are other irrational number like e, and those are also found in the equation of physics. So while we're teaching in the classroom, I mean, we straight away jump into explaining the irrational number, but we do not take a pause and find out why these numbers are so great. All right, so this is another topic for you to think about. What's prime about prime number? So prime number is called, it has been given a name of prime, and prime means something of great importance. So why it has been named prime? So something for you to think about. I will conclude my presentation with this slide. You have to teach about Taj Mahal in your classroom. Would you start by giving them the number of rooms that Taj Mahal has, or any facts about Taj Mahal? Or would you rather describe the beauty of it? I mean, how marvelous, how magnificent it is. Now, it is easy in the case of Taj Mahal is because it is all visible. We can see it, we can feel it. But especially in the case of science and maths, many a times the beauty of the concepts are hidden. They are out there, but they are not so much visible in front. And it is the role of the teachers to give time, synthesize, find the beauty, and present in the classroom. So this is how you can incorporate in your school system. Give time on developing your own love for the concepts. So as a teacher, we have a busy schedule, and our focus remains on teaching the concepts somehow and covering the syllabus. But we must take a pause and we must develop our own love for the subject. So here we are with our second conclusion is again thinking and study time for the teachers. So first one was thinking time for students, and this is thinking time for the teachers, which is very very important, especially in this age of technology where everything happens in a moment and we do not take a break to reflect and think about uh, the things that we are teaching, rediscover and appreciate the concepts. Thank you so much. And if you have questions, I'd be happy
Thank you,
to.
Abhishek. We have a question, so I just request I will just email you on that because due to lack of time, we can't take questions right now. And I
All right.
request all the audience, such a wonderful presentation was given by Abhishek that gave us to think right now that are we really on the right track or not. And I request all my audience, if you want to avail the solutions and avail the innovation done by the Open Door, we have a booth of Open Door and team is available of Open Door in the exhibition area also. You can directly ping them and they will reach out to you. Abhishek and his team will be there to help you out what regarding your uh, study, regarding your curriculum, regarding your pedagogy. So thank you, Abhishek. Thank you for joining 17th World Education Summit and enlightening us with this such a wonderful presentation. And we are looking forward for such more presentation in our upcoming summit. And this is a token of appreciation for given by 17th World Education Summit. A speaker certificate is presented to the Abhishek Kariwal, co-founder of Open Door Education. Thank you, Abhishek. Thank you for joining World
Thank you so
Education
much,
Summit.
Abhishek, so much. Thank you so much for giving me this opportunity to share our thoughts. And I believe that these thoughts will spread among the teachers, among the students, and we'll see some change coming going forward. Thank you so much.
100%. Thank you, Abhishek. Thank you. Have a great day.